So we have been running this show for the last couple of years, and this is our first time at UVA. We are all very excited. We had 12 young scholars this summer. They are all brilliant. They're sitting in the front seat. I encourage you to go and meet them during the poster session. You will be impressed, I can promise you that. And we had 9 projects this summer that the teams have worked on. You can see them in the programs that you have. You will also realize that, all these projects are conducted, all the research is conducted in teams, and the teams are composed of faculty and postdocs from our division, from Sally's group, and of course our young scholars, as well as the sponsoring agencies, representatives from sponsoring agencies who are actively involved in these projects. And that's one of the strengths of our program, because the students can actually see the perspectives from these agencies, and they actually have, they feel that they have impact on policy. That's very important. And as I said, some of the agencies are actively involved, not all, some more than others, let me put it this way. But we're very happy to have them on our teams as well. And finally, I would like to also thank our administration and our communications team for keeping us in line and for making this event more professional, for making the program more professional, and making our jobs easier. Thank you.
Hi, I'm Aaron Schrader, the other half of the co-leads here for the DSPG program. We are going to lead you now into what we're calling the speed round, where everybody's going to give a quick introduction to their research this summer to tantalize you, so you're going to want to go out and get more in-depth knowledge about those projects out in the hallway at the posters. Before that, just to say something nice about these guys. It sounds completely trite, because I have to admit I've said it before, but this has been the best group so far. That we've had. Yeah, I mean, I've said it, and we've hired people from our past groups, so this is nothing on you folks. You're still great. But in terms of representing the type of model that we are very purposefully trying to build here in the DSPG program, I think this group is we're just getting better and better every year. And in that model, we're really trying to effectuate the creation of data scientists with really just 2 main qualities. One is you have a desire to make big effects on the public good, right? You want to use your powers for good, right? But you have a very strong desire to do so. And then 2, regardless of the background you're coming from, you have a fearless desire to learn, right? Some of you came from non-technical backgrounds, some have technical, some from one thing and another, but everybody had to have that ferocity to learn within a very short period of time the tools you needed to carry forward your mission on doing some form of public good. And this group just did a terrific job of that. Just thinking about the diversity of backgrounds that we brought in this year, off the top of my head, I wrote down statistical sciences, sociology, psychology, cognitive sciences, economics, urban planning, computer modeling, of course, and public policy, right? Very heterogeneous group. And then given the way I think about things athletically, geographically, we've got the ACC, the Big East, the Big Ten, and the Ivy Leagues all combining together for forces of good, which has just been terrific. But rather than me talk about them anymore, let's go ahead and start the speed round.
Hi, my name is Alyssa Fowers. I am a graduate student at the University of Miami studying data visualization. I'm here representing the Skilled Technical Work team. We worked with the National Center for Science and Engineering Statistics within the National Science Foundation. You'll hear that a couple times. The next 3 teams all worked with NCSES as well. So my team focused on the skilled technical workforce, so that is people who are in technical occupations that don't necessarily require a bachelor's degree. These occupations are really critical for American industry, as well as serving as a pathway into the middle class for the people who have these jobs. So we focused in on critical care nurses in Richmond, Virginia, and we were able to pioneer some new methods for finding really in-demand skills and measuring the match between individual candidates and job ads. So I really loved working on this project because it was great fun to invent some new methods and to dig into some really rich and some really rich and new data sources. So I hope you'll come and take a look.
Hello, my name is Calvin Ish. I study cognitive science at Indiana University, and today I will be presenting our work on the OSS project, open source software. For this, our sponsor was the amazing Carol Robbins from NCSES. And if you don't know, open source software is the code behind many of the things that you probably use every day. It's in smartphones, and it's in the code programs that we use to make all of the posters. So it's everywhere. But right now, there really isn't a good way of measuring open source innovation outside of the business sector. So this project kind of takes a first stab at trying to measure how much is out there, who's creating it, and where they're from. If any of that sounds interesting, or if you're interested in the future of software, please check us out.
Thanks. Good afternoon. My name is Quinton Neville. I'm a graduate student at Columbia University studying biostatistics. And this summer, my team and I delved into developing methods for machine learning methods for identifying innovation in news articles. So our sponsor is Gary Anderson, who's unfortunately not with us here today, but also from the NCSES. So machine learning, what a buzzword. So it's like artificial intelligence, big data, and even data science. It's become a really ubiquitous part of our lives. It's in the technology that we carry around with us every day. We use it all the time, and it's become very important. And it's become important for a very good reason. It's incredibly useful. But it's not nearly as mysterious as a lot of people oftentimes think it is. It's just a lot of fancy math, statistics, and telling a computer to execute some things for you. And so for our purposes, we we explored some existing methods for text classification in order to predict innovation, but we also looked into some really novel methods, specifically in the world of neural networks. And so that's all really great, but why are we so interested in predicting innovation in the first place? We're interested, or the NCSES is interested, because innovation is oftentimes used as a great indicator for economic growth and well-being. And so yearly, they conduct a survey to try to measure innovation. So our job is to basically try to supplement this using alternative methods, some new methods, in order to detect innovation. So if that sounds like your cup of tea, you can come join us at our poster, and we can chat a little bit more about it.
Each person can be in the middle. Yeah.
Hello, everyone. My name is Sean Petrowitz. I am an undergraduate student at the University of Notre Dame studying applied computational math and statistics, and I'm going to be introducing the public R&D project. So in this era of big data, there's more and more federal government spending databases available to the public. And so we wanted to look into these spending databases to see if we could extract useful information about research and development funding. So right now, our sponsors at NCSES administer a yearly survey that tells how much research and development funding there is by each agency. But what if you wanted more detail? What if you wanted to know funding information for the individual projects that comprise these totals? So we looked into using these big data sources to try to supplement this NCSES survey and try to match the results. So if you check out our poster, you'll be able to see how close we were able to get and some of our methods.
Hi, my name is Sarah McDonald, and I am a senior at Marymount University studying math and economics. I wanted to invite you all to check out our broadband poster. The purpose of our broadband project was to validate the FCC broadband data. Just for reference, the FCC says that 25 million Americans do not have access to broadband. The Microsoft Airband initiative says that 165 Americans do not use the internet at broadband speeds. So to validate the FCC data, we compared it to the American Community Survey broadband data as well as the Microsoft data. We found discrepancies between the different sources and differences between urban and rural counties. So please come check out our poster.
Hi, good afternoon, everyone. My name is Raghav Sani, and I'm a senior at Virginia Tech, majoring in computational modeling and data analytics. I'm also on the team Broadband. And as Sarah just mentioned, our main focus for our summer project was to try and validate the FCC broadband availability data. We wanted to visualize the discrepancy in the coverage percentage between the FCC and all the other data sources we aggregated, each of which were actually reported on a different geographical level. Our team has made an interactive dashboard that allows the user to select the state of his or her choice, to select, allows them to choose which geographical level they want to look at, and also helps subset the region based on whether it falls in an urban or rural area. You could check out our dashboard on your smartphone or on our screen, which we have next to our poster. And if you would like to know the coverage of the area you're living in, definitely check our poster out. Thank you.
Hi, my name is Tong Tong. I'm from the University of Illinois at Urbana-Champaign, and I'm a PhD student in urban planning.
Hi, I'm Eliza Tobin. I'm a fourth year from the University of Virginia studying public policy.
So our project is called Fairfax County Communityscape. So we know that socioeconomic factors and the lack of access to resources usually place some of the disadvantaged groups at higher risk of health issues. So we explored that problem. We partnered with Fairfax County and Innova Translational Medicine Institute to create a communityscape that describes the disparity in economic vulnerability and obesogenic environment in Fairfax County.
So as Song said, our project aimed to map vulnerable populations in Fairfax County. We did this by creating composite indices using publicly available data, and we looked at 3 distinct geographies: census tracts, high school districts, and supervisor districts, and we were able to actually pinpoint the geographies within these areas where populations were most at risk of economic vulnerability and of exposure to obesogenic environments. We think that this is particularly useful for policymakers, as they'll be able to identify the populations that are most in need of support, and they'll be able to write especially actionable policy. You guys should come check us out. Our project is actually so cool that we have not 1 poster, but 2.
Hello, my name is Jessica Keast, and I am a rising senior at Smith College studying statistical and data sciences. This summer, one of my projects has been working with the Army Research Institute to define community embeddedness. If you've ever wondered why people stay where they live, we have some answers for you. Our project conceptualizes what makes it difficult to leave a given place based on the social determinants of health, which encompasses the built environment, community, education, healthcare, and economic stability. So we've used all these to create a community embeddedness index, which we've explored at the county level in both Oklahoma and Virginia. We were really surprised by what we found and would love to tell you more about it, so stop by our poster.
Hi everyone, I'm Allegra Posinki. I am a PhD student in sociology at Rutgers University, and I'm here to present on the Returning Citizens Reentry Project, which is partnered through Resilience Education, which is actually a program at the Darden School of Business. It's a cooperation between the Darden School of Business and 2 prisons in Virginia. So basically, Darden MBA students go to teach prison entrepreneurship classes to inmates in 2 prisons, a men's prison and a women's prison. And so for this project, we actually gathered information on all sorts of prison education programs across the U.S. and gathered best practices and things that we think should be included in any sort of prison education program in terms of what data they should be collecting to measure the program's effectiveness. So if you're interested in that, you should come check out our poster.
Hi, everybody. My name is Victoria, and I'm a recent graduate from the University of Illinois at Urbana-Champaign, and I studied cognitive psychology. So my team has partnered with the Arlington County Police Department, and their restaurant initiative seeks to reduce the occurrence of alcohol-related crimes. And part of their program involves training bar staff and bar managers with ways to not only address, but also prevent these crimes before they happen. So over the summer, we have been compiling the data to tackle the question of whether this initiative is reducing alcohol-related crime. And, well, I guess consider the economic and the social elements of this program. So our poster and our interactive dashboard visualize this data, and we'll show you our methods for tackling such a vital question. So we invite you all to check those out. Thank you.
Hey, my name is Patrick Corbett. I'm an intern under Dr. Brian Lewis at UVA's Biocomplexity Institute, the Advanced Computing Division. So I've been pretty much helping him, Dr. Schlitt, and Dr. Schwarup visualize a project that's creating synthetic data for modeling and simulation purposes. The goal of the project pretty much is creating a simulated model society with a high number of individuals. Each individual is kind of analyzed for certain actions or interactions that could commit in this simulated society. And the interactions are evaluated at a very high time scale resolution over units of seconds over the course of 4 weeks. Overall, I show kind of the spatial temporal resolution, the distributions of this data set I can create through the model. And to the best of our knowledge, it's one of the most comprehensive models of this kind of population interaction kind due to like the scale and the resolution that we have. And this is all data that would be very difficult, if not impossible, maybe hopefully impossible to gather in real life. So this kind of creates an opportunity to create a model and kind of serves the framework that might be able to be used to do some interesting things like a model like potential infectious disease spread or more chronic disease spread, or maybe detect bad actors in society. It has many potential applications without actually having to gather this data in real life. So, yep.
Thank you.